Now for the solutions to the quiz at the end of lesson 3.3. Now firstly, we know that capacitance is E0 A over D. So you press the button, D decreases, and that means that C increases since D is on the bottom, so that is A. Second one, we have capacitance is charge over voltage. Now voltage is the same. So if B has a capacitance that is half A, so we have Q equals C times V, and V is a constant. If C was a half, then Q would be a half as well. So that's B. Now number 3, we have the spot where it has discharged to the time constant. It's 37% or 0.37 of the peak voltage. We can read the peak voltage is about 6.4 volts. So we want to know at what time is V 0.37 times 6.4 or 2.4 volts, and it is closest to 15 seconds, so that is B. Now number 4, we have capacitance 1 is 2 microfarads, C2 is 4 microfarads. So the total, since they're in parallel, we just add them. C1 plus C2, so that is 6 microfarads. Then charge equals the total capacitance times V, so V is the total charge over the total capacitance, which is 5.4 by 10 to the minus 5 over 6 by 10 to the minus 6, and that equals 9 volts. Now question 5. Firstly, when capacitors are in series, we have 1 over the total capacitance, 1 over C1 plus 1 over C2. So we have 1 over 1 by 10 to the minus 3 plus 1 over 1 by 10 to the minus 3. Now we can continue to work this out and get that then CT equals 0.5 by 10 to the minus 3, or you could just remember that when they're equal capacitances in series, then the total will be half. It's just like resistors in parallel. Now, when they're in parallel, that's where, just like resistors in series, we simply add them. So the total is 2 millifarads. So then for part B, the time constant is R times C. So the time constant for the series circuit, it is R times the capacitance of the series circuit, which is 1 by 10 to the 3 ohms times 0.5 by 10 to the minus 3 farads, which equals 0.5 seconds, where the parallel time constant is going to be 1 by 10 cubed times 2 by 10 to the minus 3, and that gives 2 seconds. And now for our circuit question. The first thing we know that the voltage across R1 has to equal the voltage across R2, since they're in parallel. And from Ohm's law, we have that voltage equals the current times the resistance. So we have 3 amps times 2.7 ohms. So that means 8.10 volts. And that means the current in R2, so we'll call it R2, is just again Ohm's law, V over R2, which is 8.1 over 4.4, and that equals 1.84 amps.